Okay guys, this is the Integrated Math 3 Spring Semester Final Exam Review. Just to let you guys know, I am not going to do every single problem in this review. I'm going to go ahead and pick and choose the ones that I feel you guys need the most. Also, I'm going to go a little bit fast on these problems because I want to make this video shorter than the ones that I've previously made. So just you have the ability to pause the video whenever you feel like it, right? So that's my thinking here. So if I go fast, just go ahead and pause it, okay? Just stop it a little while, think about what you're doing, write it down, and then continue playing the video. Okay, so here we go. We're going to start with number 1, part E. Okay, so in number 1, part E, we're going to be solving for x here. The equation is x cubed plus 8x squared plus 17x plus 6. So what you have is a cubic equation, and you need to solve it. Your first go-to process should be to factor by grouping, if possible. Okay, so that's what we're going to do. We're going to try to factor by grouping. If it doesn't work, then we'll go to synthetic division to see if we can find any solutions that way. So here we go. I'm going to group these two. I'm going to group these two, and I'm going to try to factor. Okay. So for the first pair, I am going to factor out x squared, leaving me with x plus 8. For the second pair, there's really nothing I can factor, right? So basically what you say is I factor out 1, and it leaves me with 17x plus 6. And at that point, you notice that it doesn't work, right? You cannot factor by grouping. So what we're going to do instead is to do synthetic division. Okay, to do synthetic division, what you do is you look at the C value. Well, it's not really C in this case, it's D. It's the very last term, right there. And what you do is you try to figure out what factors does that number have. Okay, usually we look at that term and in addition to the A value, right, the leading coefficient. And we make a fraction out of them, 6 over 1. We come up with all the different factors of 6 and all the different factors of 1, including the positives and the negatives. In this case, since this is 1, we just have to worry about the 6. So the possible factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So we're going to test those out using synthetic division until we find 1. We only need to find 1 because this is a cubic function. So if we found one factor, that means that what we have left is going to be a quadratic. And if we have a quadratic, it's much easier to do that factoring by grouping or by using the quadratic formula. So let's start. I'm going to start with 1 as my first number to test. 1, 8, 17, 6. So let's see if you guys recall factoring by grouping. The first thing you do is bring this number down, and then you multiply, then you combine, then you multiply, then you combine, then you multiply, then you combine, right? So let's do it. Bring down the 1. 1 times 1 is 1. 8 plus 1 is 9. 1 times 9 is 9. 17 and 9 make 26. 1 times 26 makes 26. 26 and 26 makes 32. That doesn't work. Okay? So let's erase this and try negative 1. Here we go. Negative 1 times 1 is negative 1. 8 minus 1 is 7. Negative 1 times 7 is negative 7. 17 minus 7 is 10. Negative 1 times 10 is negative 10. And that's negative 4. And that doesn't work again. Remember, the goal is to have a 0 here at the end. So that doesn't work. Let's get rid of that. We're going to try 2 and negative 2. Bring down the 1. 2 times 1 is 2. 8 and 2 makes 10. 2 times 10 is 20. 17 and 20 makes 37. 2 times 37 is going to be 74. That gives me 80. And again, that doesn't work. Let's keep trying. We're going to try negative 2. Bring down the 1. Negative 2 times 1 is negative 2. That's 6. Negative 2 times 6 is negative 12. That's 5. Negative 2 times 5 is negative 10. And that's negative 4. And once again, it did not work. Let's get rid of that and try 3. Bring down the 1. 3 times 1 is 3. 8 and 3 makes 11. 3 times 11 is 33. 17 and 33 make 50. Is that right? Yeah, that's right. 3 times 50 is 150, so that's 156. Again, that didn't work. Alright. Good news is that we only have a few left to try, so it's not like we're going to be doing this forever. Let's try negative 3. Okay, here we go. Bring down the 1. Negative 3 times 1 is negative 3. 8 minus 3 is 5. Negative 3 times 5 is negative 15. 17 minus 15 is 2. Negative 3 times 2 is negative 6. There it is. We found it. 6 and negative 6 gives me 0. We have found one of the solutions, which is negative 3. So x equals negative, x equals negative 3 is the first solution. We need to find two more, right? This is a cubic function. So what I'm going to do at this point, since we found negative 3, is I'm going to take these three numbers and turn it into a quadratic. Remember, we started with the cubic, so if you factor one out, this is a quadratic right here. So what this represents is x squared plus 5x plus 2 equals 0. Now I'm going to try to solve that. Okay, I'm going to start by trying to figure out if there's common factors. 1 and 2 make 2, right? So some of you guys are familiar with this as x factor. Two numbers that you multiply to make 2, but when you combine them, they make 5. And you should realize that there is nothing. Right? 1 times 2 or negative 1 times negative 2 are the only options, but neither of those makes 5. So this doesn't work. Which means that if you can't factor this, the only option you have left is to solve this final part using the quadratic formula, which is what I'm going to do right now. I'm going to punch all these into the quadratic formula, which I'm going to refresh your memory with right now. It goes like this. X equals negative b, that's a negative, plus or minus the square root b squared minus 4ac all over 2a. In this case, a is 1, b is 5, so right here I'm going to put 5 and 5, and c is 2. So let's punch those in. X equals negative 5 plus or minus the square root of 5 squared, which is 25, minus 4 times 1 times 2, so minus 8. Be careful when you do that step. All over 2. 2 times 1, which is 2. Okay. X equals. So let's finish simplifying this. This is negative 5 plus or minus the square root of 25 minus 8. 25 minus 8 is going to be 17, right? Radical 17 all over 2. And those are your other two solutions right there. X equals, I'm going to separate them out, negative 5 plus radical 17 all over 2, or x equals negative 5 minus radical 17 all over 2. Those are the three solutions to this equation. Okay, the next one I'm going to do is number 2, part C. In this problem, you have a rational equation. We call these rational equations because they are made up of fractions and there's variables in the denominator, right? Whenever you have that, we call it a rational equation, which comes from the word ratio for fraction, right? So what you need to focus on all these problems is to find the LCD, the least common denominator, meaning make all the denominators the same, the least common denominator that they all have, right? So the way you should figure that out is to look at the denominators, and you're basically looking for what's missing, right? If you look at this denominator and you compare it to the other ones, what's missing from this one? And your answer should be nothing, right? It has the x plus 3 that this one has. It has the x minus 5 that this one has. So basically you're saying, do the other denominators have something that this one does not? And the answer is no, right? It has everything. And by the way, you should always do this once the denominators are factored. If the denominators are not factored, then don't even ask that question. Factor them first. In this case, they are. Now let's look at the second one. If I look at this denominator compared to the other ones, what's missing? And you should see it's missing x minus 5, right? So that's what's missing from this one. What about this one? And you should see x plus 3, right? This is what's missing from this one is x plus 3 because the other ones have it and this one does not. Okay, so that's what we're going to do. We're going to give them those denominators by multiplying times that denominator times a denominator, a fraction that is equal to 1, but that has that same term in the numerator and the denominator. Okay, so it's going to look like this. The first one is missing nothing, so we're just going to write it exactly as it is. X plus 4 equals over x plus 3 times x minus 5, exactly the same. But for that second one, which looks like this, I am going to multiply it times x minus 5 over x minus 5 because that's the factor that's missing from it. The one on the right, 16 over x minus 5, we're going to do the same thing to it. We're going to multiply it times x plus 3, that's a 3, over x plus 3, right? The missing factor from that denominator is x plus 3. There you go, multiply those out. So the first one is basically still the same. X plus 4 over x plus 3, x minus 5. The next fraction right here, I'm going to distribute the 3 here, and I'm just going to leave these next to each other, just the same way they are in this fraction over here. So it's going to be 3x minus 15 over x plus 3 times x minus 5. The last one, I'm going to do the same thing. I'm going to multiply the 16. I'm going to distribute it. So it's going to be 16x plus 48 over, once again, the same denominator, x plus 3, x minus 5. At this point, what we do is we basically cancel all the denominators because they're all the same. That's really not what's happening, although you can think of it that way. But really what's happening is that we're multiplying the entire equation on both sides times x plus 3, x minus 5. That's really what's happening. And that allows us to cancel that with all of the denominators, basically. Okay? But you can just think of it, as soon as you see that all the denominators are the same, then you can just cancel them. They're all gone. Which allows us to continue our equation with a much easier problem. Basically, what we have left now is x plus 4 plus 3x minus 15 equals 16x plus 48. So now what we're going to do is we're going to combine like terms here on the left side. X and 3x make 4x. 16x plus 48. We're going to subtract 4x. (12x plus 48). We're going to subtract 48. That's negative 59 equals 12x. Divide by 12, and there you go. X is equal to negative 59 over 12. That's your final answer. Alright, the next one we're going to try is number 3, part A, finding the inverse of a function. Okay, so we have f of x equals x over 2 minus 6. First thing you're going to do here is change f of x to y. It makes your job so much easier. It makes the work so much easier. Next, what you're going to do when you're finding the inverse is to isolate the x. That's your goal. You want to isolate the variable that is not isolated, right? In this case, it's y that is isolated. We want the opposite. We want x to be isolated. So the first thing we're going to do is get rid of the 6. We're going to add 6 to both sides. This is y plus 6 equals x over 2. We're going to multiply times 2 on both sides, times 2 on this side as well. So we get x equals 2y plus 12, right? Because I distributed 2 right there. Next, what you're going to do is, the definition of the inverse is that you're switching your variables, right? The x and the y are switching with each other. So you're going to write these by switching the x and the y. It's going to be y equals 2x plus 12. And finally, change that y to f inverse to write it in the proper format. And there you go. You're done. Okay, next is number 5. It says that water is flowing through both a small pipe and a large pipe, and it can fill a water tank in 9 hours. Water flowing through the large pipe alone can fill the tank in 17 hours. Write an equation that can be used to find the amount of time, t, in hours it would take to fill the tank using only the small pipe. The idea here, guys, is that work rate, because both of these pipes are working, work rate can be added together. You can combine two different things working at the same time to make things go faster. Okay, so basically the idea is here that the rate of the small pipe plus the rate of the large pipe is equal to the rate of both pipes together. We're going to call that R sub B. And what I mean by rate is how fast does that pipe actually work. So if you just think about the small pipe, what we know is that, we don't know actually. All we know is what it is for both pipes together and what it would be for the large pipe by itself. We don't know about the small pipe by itself. That's actually the question that they're asking us. So you know what? Let's focus on the large pipe then. The large pipe, it says, can fill the tank in 17 hours. So its rate is 1 tank every 17 hours. 1 tank every 17 hours, right? Or 1/17 of a tank per hour is the way you can think of it as well. Okay, but basically, how much can it fill? 1 tank. How long does it take it? 17 hours. That's its work rate. For both of the pipes together, they can fill 1 tank, but much faster than 17 hours. Together, it takes them 9 hours, right? That's right here. Both the pipes together can do it in 9 hours. So that's the combination of both pipes. For the small pipe, that's what they're asking us about. So how long would it take the small pipe to fill 1 tank? We don't know. We'll call it T. And there's your equation. So what I'm going to do now is try to figure out the common denominator, just like we did in the previous problem in number 2. Find the common denominator, meaning ask what each one is missing. Okay, so let's go through them. If I look at this denominator and this denominator and this denominator, look at each one individually. Here's this one, which is T. What's missing from this one? The 17 and the 9, right? It's missing both of those two things. So I'm going to multiply that one by 17 times 9, whatever that happens to be. The next one, 1 over 17, is missing the T and the 9, right? It has the 17, it's missing T and 9. So I'm going to multiply that one by 9T over 9T, because it's missing both of those things. And the fraction on the right, 1 over 9, it's missing T and 17, so 17T. Alright, so if I continue here, this is going to be 153, because 17 times 9 is 153, over 153T. The next one is going to be 9T over 153T. And the last one is going to be 17T over 153T. Right? So they all have the same denominator. I can do the exact same thing I did in that last problem. I can just go through and cancel them all. Really, you're multiplying all the way through with 153T, and that's what cancels them, but that's what ends up happening. So if I continue from there, I'm going to continue up here. We have 153 plus 9T equals 17T. And all I got to do now is subtract 9T from both sides. I get 153 equals 8T. And then I divide by 8. And T is equal to 153 divided by 8, which my calculator says is 19.1. 19.1 hours for the small pipe to fill the tank by itself. And that makes sense, right? The small pipe should be slower than the large pipe by itself, and then the both pipes together. Both pipes together should be faster. Alright, the next one I'm doing is number 6. It says the height in feet of a ball thrown by Alex is y equals negative 1/4 x squared plus 4x plus 5, where y is the horizontal distance in feet when the ball is thrown. Okay, so there must be a typo here. Y cannot be the horizontal distance. Y must be the vertical distance. So let's cut that and put vertical instead. Because if y was the vertical distance, then it would pretty much be Yeah, that wouldn't make sense, right? X has to be the horizontal, or X is time, but Y is always going to be the vertical distance. So let's write it that way, and then we're going to find the maximum height. So here we go. What we're going to do, it says to graph it and find the maximum height. Okay, and you can do that. Use the graphing calculator, punch it in, go to the second calculate menu, which is under the trace button in your graphing calculators, and use the maximum, right? Find the maximum that way. Okay, I'm going to do it without having to use the calculator, which is actually a very simple process. What you need to do, what it's really asking when it's asking for the maximum height, is it's asking you for the vertex. What's the vertex of this parabola? And I know this is a parabola because it says x squared. So we're going to find the vertex using x equals negative b over 2a, which is the way we find the vertex every single time. In this case, b is 4, so it's negative 4 over 2 times negative 1/4, which is 1/2. Think about the way I did that. It's 2 times negative 1/4. That's going to give you that's negative 1/2. And then negative 4 divided by negative 1/2 is going to be positive 8. And you can check that. So x equals negative 8. That's still not the maximum height. The maximum height is y, but that is the x coordinate of my vertex. What I'm going to do with that is plug it into my original function. Whatever I get for y, that is the maximum height, because that's where the vertex is. So let's punch it in. We're going to get y equals negative 1/4 times 8 squared plus 4 times 8 plus 5. So that's going to be 8 squared is 64, so negative 1/4 times 64 plus 32 plus 5. 64 divided by 4 is 16, so that's negative 16 plus 32 plus 5. These two are 16, so 16 plus 5 is 21. The maximum height is 21 for this ball. In feet. That's what it says right there, feet. So feet. 21 feet. Alright, the next one I'm going to do is number 7, part B. State the transformations of g of x equals 2/3 times the square root of x minus 4 plus 5 from the parent function. So what you do in all of these problems is find b, h, a, and k. And once you find that, you could pretty much tell what the transformations are by looking at the values of those those variables, those parameters, I mean. So b is 1. Remember, b is always next to x. Wherever x is, next to it is b, so it's just 1 right there. And it's always 1 over b, but in this case, it's 1 regardless, right? H is inside with the x. It's either being added or subtracted from x, so there it is. H is 4, because it's always supposed to be x minus h, right? So in this case, it's positive 4. A is out here in front, always, 2/3. And k is 5. And using that, I can pretty much figure out what's happening to the function, what the transformations are. So for example, b is 1 means that there is no vertical stretch, no horizontal stretch, no horizontal compression, no reflection. B has no effect because it's just 1. But H means that there is a horizontal translation right? B and H are always horizontal, remember that? Horizontal translation to the right 4 units. Right? It's to the right 4 units because it's positive 4. A always represents a vertical stretch or compression or a reflection if it's negative. It's not negative, so it's not a reflection. And then how do you decide if it's a compression or a stretch? Is by looking at how big the number is. Anything bigger than 1 is a stretch. Anything smaller than 1 is a compression. This is smaller than 1, so it's a compression. Compression by a factor of 2/3. K represents a vertical translation, and this one means up 4. Up 4. There you go. And that's it for that one. Alright, next one I'm doing is 8b. It says graph y equals the cube root of x minus 4 plus 2. Right? Anytime you have to graph one of these, what you should do is find b, h, a, and k, which is what I'm going to do right now. b, h, a, and k. And that's what's going to allow you to do the transformation. Let's fix this because those don't look like equal signs. B, H, A, and K. In this case, B is next to X, right? That's just 1. H is also inside there with X. In this case, it's 4. A is 1 also because it's always out here in front. Since I don't see anything there, that's a 1. And K is positive 2. This is going to be an easy transformation. Okay, what you do next is you set up your parent function table, which in this case it's a cube root. So you must remember this table: -8, -1, 0, 1, 8. And then the y values are -2, -1, 0, 1, 2. It's negative. And we're going to transform it, and that's a 0. We're going to transform this table using our B, H, A, and K. Which, remember, the B and the H are things you do to the X value. The A and the K are things you do to the Y value. And they have the exact same effects. B is multiply, H is add or subtract. A is multiply, K is add or subtract. In this case, they're both positive, so they're both added. Now, since B is 1, you really don't even have to worry about it, right? Because when you multiply times 1, nothing changes. So we're only going to worry about H and K. To the X values, we're going to add 4. To the Y values, we're going to add 2. And that'll give us our new table, which will look like this. The X values are all added 4, so it's -4, 3, 4, 3. Whoop, that's not right. That's 5, right? And 12. The Y values are going to add 2, so that's 0, 1, 2, 3, 4. I added 2 to all of them. And there you go. Go ahead and plot those points into a coordinate plane, and you're basically set. Cube root functions do not have an asymptote, so you don't have to worry about asymptotes at any point here. All you got to do is just draw your x-axis and your y-axis, plot your points, and make your curve. Here we go. -4, 0. That's there. Right about there. 3, 1. Right here. 4, 2. 4, 2. Right here. 5, 3. 5, 3. Right here. And 12, 4 is like way out here. Right? So that should be enough for me to draw it. I'm going to go ahead and draw it with what I have right now. It looks something like this. It goes this way, then it goes up, then it curves again. That way. Like that. Alright, next one I'm going to do is number 9, part B. It says graph the function, then describe the horizontal and vertical asymptotes of the function. So this is a rational function, right? It's just like A, except you can't easily see what A, B, H, A, and K are in this case. So what you got to do is you've got to fix it. You got to make it so that you can actually see those parameters. So what you're going to do is you're going to divide, right? This means x minus 4 divided by x plus 5. So that's exactly what I'm going to do. I'm going to use a little bit of long division to divide this. X minus 4. Fix that. X minus 4 divided by x plus 5. And what you want to do is you try to figure out how many times does x go into this x right here. X times what gives you x? And you should say 1. And what you do is you do the exact same thing you do with long division. You take that 1, you multiply times both of them, and you write it here. 1 times x is x. 1 times 5 is positive 5. And what you're going to do here is you're going to subtract. That's the rule, right? For division, you subtract that. X minus x is going to cancel. -4 minus 5 is -9. And you're done. This is your solution. 1 plus -9 over x plus 5, right? You always put your remainder over your divisor there. I'm going to flip those around to put the 1 at the end and put the negative 9 over x plus 5 first. So it looks like this. Negative 9 over x plus 5 plus 1. And using that as my function, I can now tell what the transformations are. Negative 9 over x plus 5 plus 1. That's my function. So what you can do now is look at that. I'm erasing this to make space. Look at that and figure out that b is 1, because b is always next to x down here. H is negative 5, right? Because h is over here next to x. A is negative 9. A is either in the denominator or outside the fraction over here. And k is 1. And so using those 4 parameters, I can transform my function. And my original parent function for these types rational functions is going to be one of the easiest, if not the easiest, parent function table I asked you guys to memorize. Negative 1 gives you negative 1, 1 gives you 1. Starting with that, using b, h, a, and k, you can transform your table. Okay, so let's quickly do that. Since b is just 1, I don't have to worry about it. So we're just going to worry about h, a, and k. For h, I need to subtract 5 from the x values, right? That's the correct process. So negative 1 minus 5 is negative 6. 1 minus 5 is negative 4. For a and k, first I multiply times negative 9, then I add 1 to the y values. So let's do that in our heads real quick. Negative 1 times negative 9 is 9. 9 plus 1 is 10. 1, I'm looking here, times negative 9 is negative 9. Plus 1 is negative 8. Okay, the last thing I need to recall before I graph it is that my h value and my k value in these functions are always my asymptotes. So h equals negative 5 is an asymptote. It means x equals negative 5. It means a vertical asymptote. And k equals 1 is a horizontal asymptote. I'm going to put that here. This is a vertical asymptote right there, and this is a horizontal asymptote. So using that and using these 2 points right here, I can now make my graph. Watch. Here we go. We're gonna make a graph like that. We're going to let's see the asymptotes first. H equals negative 5. So 1, 2, 3, 4, 5. There's an asymptote right here. K equals 1. There's an asymptote right there. And now I can plot my points. Negative 6, 10. 1, 2, 3, 4, 5, 6, 10. All the way up there. 5, 6, 7, 8, 9, 10. Right about here is a point. And negative 4, negative 8. That means go to the left 4. 1, 2, 3, 4. And then down 8. 1, 2, 3, 4. And then down 8. 1, 2, 3, 4, 5, 6, 7, 8. Right about here. And that is enough to draw your graph, because you know that the asymptotes are magnets that pull the graph towards them. So it's going to look something like that on that side, and like that on this side. Alright, so the next one I'm doing is number 11, part B. It says to identify the roots and state the multiplicity of each root, then determine whether the graph crosses or is tangent to the roots. Okay, so we have x cubed minus 3x plus 3x minus 1. That's a typo. It should say minus 3x squared. So let's fix that. X cubed minus 3x squared plus 3x minus 1. What you're going to do is use factoring by grouping, hopefully. If that doesn't work, then you're going to use synthetic division. But you know what? I'm looking at it, and I don't think factoring by grouping works at all. So we're going to go straight to synthetic division. Okay, the factors that I'm going to test out are factors of 1, which is either 1 or negative 1. That's about it. Those are the only options I have. Okay, so using synthetic division, we have 1, negative 3, positive 3, and negative 1. And what we're going to test out first is, let's test out 1. So here we go. Bring down the 1. 1 times 1 is 1. That's negative 2. That's negative 2. that's positive 1, that's 1, that's 0, we got 1. My first factor, my first solution is x equals 1, right? Now we have to figure out more, so we have 1 minus 2 and negative 1 as my remaining numbers here. I'm going to turn that into a quadratic, as I've done in the past. This is x squared minus 2x plus 1 equals 0. We're going to try to factor that out. Two numbers that multiply to make 1, but when you combine them together, they make negative 2. Negative 1 and negative 1. Yeah, that's it. Negative 1 and negative 1. So then that leaves me with, for this particular expression right here, it's x minus 1 times x minus 1 equals 0, which gives me x equals 1 and x equals 1 again. That's exactly the same thing I got over here, but all of them are x equals 1. So how do you write this? You say the solution is x equals 1 with the multiplicity of 3, because that same solution happens 3 times. Now, what does that represent? If you were to graph this function, it would cross the x-axis at x equals 1. Since the multiplicity is 3, which is odd, it crosses. Okay, what you have to remember is ET, OC. ET means that if it's even, it's tangent. If it's odd, it crosses. And we're talking about the multiplicity here, not about the actual number, the actual value of the solution, but the multiplicity. The multiplicity is 3. That's odd, so it crosses. It will cross here. Crosses. Done. Okay, next we're going to do number 13b. 2x to the fourth minus 2x cubed minus 12x squared, and it says completely factor this. So what I'm going to do is factor out the GCF first, and then see if I can continue factoring after that. So let's see. I notice that they all have a 2 and an x squared in common. So we're going to factor out 2x squared, leaving me with x squared minus x minus 6. Check my work, make sure that I'm doing this correctly. I'm going to try to factor the remaining trinomial here inside. X squared minus x minus 6. What I have is a negative 6, and I need to figure out two numbers that when I multiply them, they make negative 6, but when I combine them, they make negative 1. I'm thinking 3 and 2, and the 3 is negative. Yep. So that actually, since the coefficient here is 1, I can already say that the factors are 2x squared, x minus 3, and x plus 2. And that's it. It's completely factored. Done. Okay, the next one I'm going to do is number 14, part B. And these two problems, what you need to do is find the domain and the range for the function. Okay, so what I'm going to do is find b, h, a, and k and use that to find the domain and the range. Okay, both of these are exponential functions. And if you recall, exponential functions have 4 basic ways that they could look. They could start up and then end flat, like that. They could start low and then end flat. They could start flat and then go up, or they could start flat and then go down. Those are the 4 basic possibilities for exponential functions. So we got to figure out what this is, and then we're going to use its b, h, a, and k to find the domain and the range. Okay. So in this case, b is e, h is 0. It does not move left or right. Oh, you know what? There's something iffy with this one. Let's see, restart. Let me erase this. What I noticed is that it says e to the negative x, which is going to throw me off. We're used to seeing just x up here, or x plus something, x plus h, x plus k, right? We're not used to seeing an actual value next to x. So what I'm going to do here is I'm going to adjust it, and I'm going to write it in this form. Equals, I'm going to put the e first. E to the negative 1 times x plus 2. Is that right? Can I do that? Yes, I can, right? Negative 1x is negative 1 times x is negative 1x, and then I can put the 2 at the end. Then I can rewrite that like this. F of x equals e to the negative 1 to the power of x. And that way I only have an x on top, which is what I like. We just want to have x. And e to the negative 1 is 1 over e. right? Remember the rules of negative exponents. You could write the reciprocal. There you go. Now it looks like I can figure this out, okay? So what I'm going to do is figure out what B, H, A, and K are. B is 1 over E, not E. H is 0, does not move left or right. A is 1, right? There is no A value. And K is 2. What determines what it looks like is your B value, basically, and your K value, right? That's what determines what's happening to this function. Your B value is 1 over E, which is a number that is smaller than 1, right? This is 0 point something. So since it's smaller than 1, that means it's decay. And if it's decay, that means that it ends flat. At the end, it's flat, right? It doesn't increase or decrease. It is decreasing and it ends flat, or it is increasing and it ends flat. That's what decay means, okay? In this case, it's a positive A value, right, which is 1, which means that it's this one right here. It's going to start up high and then decrease down to end flat. That's what happens to this function, okay? How far down does it go? It keeps going up forever, all the way to infinity. But how far down does it go? That's determined by K. Since K is 2, that means that it does not pass that value. It's going to stop at 2. It's going to approach 2, but never actually pass it. So now I know basically the domain and the range. The domain for all exponential functions is always the same. All values of x such that x is all real numbers, or you can say from negative infinity is less than x to positive infinity. It's less than positive infinity. That means x could be anything. You could plug in any value of x. There is no limitation. There is a limitation on the range because of the asymptote, right? K equals 2 represents an asymptote that it cannot cross. So the asymptote, if I recall, this is what it's going to look like. So the lowest possible value for the y is 2. It's less than y. It's less than, it's going to keep going forever all the way to positive infinity. There you go. Alright, the next one I'm going to do is number 15. I'm going to do part A. 4 to the power of 2x minus 3 equals 16. That's what we're trying to solve this equation. There's two ways I can do this. I notice that the 4 and the 16 have a common base. But I'm going to go ahead and use logarithms because that's what we practice the most usually there towards the end of this unit. Okay, so what I'm going to do is I'm going to take the logarithm of both sides, choosing my base carefully. I could use base 10. I could use base e, in which case it would mean that I could use the natural logarithm. But what I'm going to do is I'm going to use the same base as my problem originally has. Since it has a base of 4, I'm going to use base 4. Now what I'm going to do is I'm going to use the power rule, which says that I can take this exponent and bring it down. And also log base 4 of 4 is going to cancel out, which leaves me with just 2x minus 3 on the right side. On the left side I have log base 4 of 16. Which, by the way, actually, let's do that in our heads. What's log base 4 of 16? That's something that you should be able to do, right? Think of logarithms as there's the base to some power equals 16. 4 to the power of what gives me 16? You should say 2. Log base 4 of 16 is just 2. And then that's an easy equation to solve. We're going to add 3 to both sides. 2x equals 5. And so x equals 5 halves. And we're done. Or 2.5. Okay, the next one I'm going to do is number 16, part C. It says find the excluded value for the following expressions. When you're looking for excluded values, you need to concentrate on the denominator, right? You want the denominator to be 0. Actually, you don't want the denominator to be 0. That's what you don't want. So you set it equal to 0 so you could find the values that would make it 0, which is impossible to solve. So what I'm going to do is take the denominator, which is 2x squared minus x minus 10. And I'm going to set it equal to 0, and I'm going to try to solve that equation right there. What I'm going to do is try to factor it. I notice that I have a is 2 and c is negative 10, so that's negative 20. Two numbers that you multiply to make negative 20, but when you combine them together, they make negative 1. Thinking 5 and 4. One of them must be negative, which is a negative 5 right there. I'm going to use factoring by grouping to finish it here, so it's going to be 2x squared minus 5x, which comes from here, plus 4x, which comes from here, minus 10, which is my original value here, equals 0. We're going to factor both here by grouping. The first pair, I can factor out x, leaving me with 2x minus 5. The second pair, I can factor out a 2, leaving me with 2x minus 5. My factor then is 2x minus 5. That's one they have in common. And the other one is x plus 2. Set both of those equal to 0. And x plus 2 equals 0. And solve. This one's going to give me 5 halves. And this one's going to give me negative 2. And there you go. Those are your excluded values. So really we should write them like that, right? X cannot be 5 halves and x cannot be negative 2. The next one I'm going to do is number 17. It says determine whether the following functions are exponential growth, exponential decay, or neither. Okay. So what you have to remember is that exponential growth or decay looks like this. This is the basic function that you're going to get. A times B. Let's fix that. Just messed up. A times B to the power of x minus h plus k, right? Growth means that B here is bigger than 1. Decay means that B is less than 1. And exponential means that the exponent has a variable in it, right? There's an x variable up there on the exponent. That's what makes it exponential. Without it, it's not exponential. So here, the first one, I noticed that B, here's an exponent here, so it is exponential. B is a small number, right? It's less than 1, so that's decay. This one is not exponential. There is no exponent of x, right? So neither. In the next one, there's an exponent x, so it is exponential. This is a number bigger than 1, 2.3, so that's growth. In this next one, the exponent is 3, not x, right? We want the exponent to be x, so this is neither. It's not exponential. In E, you have an exponent of x, that's right, that's okay, that's exponential. This is a number bigger than 1, so that is growth. And the last one, you can see that it's neither. That is not exponential at all. Okay, the next one I'm going to do is number 18, part B, x squared plus 2x minus 10. Actually, we're going to switch that negative 10 to negative 24 because otherwise we can't really factor it or cancel anything. So turn that into a 24. So here you go, x squared plus 2x minus 24. What I'm going to do first is I notice the denominator x squared minus 16 can be factored even more. So I'm going to factor that out. So in the denominator, what I'm going to have is x plus 4x minus 4. Think about where that came from. Right? X squared minus 16, perfect square, perfect square. The square root of 16 is 4, so 1 positive 4, 1 negative 4. And then the x minus 6 that was already there to begin with. For the numerator, I need to factor that out. So what I have is a times c, negative 24. Two numbers that multiply to make negative 24, but when you combine them, they make positive 2. I'm thinking 6 and 4. And one of them must be negative, which is the 4. Right? 6 times negative 4. So what I have, when I factor this out, I'm going to use factoring by grouping, is x squared minus 4x. I'm going to do the negative first and then the positive. It just makes it easier to do factoring by grouping if you do it that way. Minus 24. Factor these, group them together. I'm going to group these two and then group these two. So that's going to be x minus 4, minus 4. And in the other one, I'm going to factor out 6, and that leaves me with x minus 4 again. That's x minus 4, x plus 6. So it's x minus 4, x plus 6. Down here, we cancel the x plus, no we don't. Rewind. We can't cancel the x plus 6, but we can cancel the x minus 4. So that leaves you with x plus 6 over x plus 4 times x minus 6. Done. Okay, the next one is 19. I'm also going to do 20 here at the same time. you're going from exponential to logarithmic form. So remember, when you're doing this, focus on the base first. That's your first area of focus. Once you figure out the base, everything else comes easily. So here we go. Number 19a. The base is 2, so that's what you set up first. 2 to the power of what equals what? Okay, and when you look at it, it's 2 to the power of 4 equals 16. You always end up splitting these two, right? They are not together anymore. So 2 to the power of 4 equals 16. And the same thing happens when you're going the other way. You always end up splitting these two to turn it into a logarithmic. All right, let's keep going with b. b is the base, so it's going to be b. b to the power of what? Not 27, right? You got to split them. b to the power of 2 equals 27. That's exponential. Now for 20, you could do the same thing. Think about the base first. The base is 5, so you start with log base 5 of what equals what? And it can't be 2, because remember, you're splitting them. They're not together anymore. So log base 5 of 25 equals 2. Same thing down here. The base is x, so log base x of 243 equals 5. Done. 21, finding the area of triangles. For A, you should not be struggling. Use the formula that you know, that you learned back in 4th grade. 1/2 base times height. They gave you the base, they gave you the height, just plug it into the formula. Okay. But B and C, you need the new formula that we learned this year for triangles where they don't give you the base and they don't give you the height. What you can use is 1/2 A times B times sine of C, which really means find two sides and the angle between them, the angle that is included by those two sides, find the sine of that angle and then just multiply everything together times 1/2. So for C, which is the one I'm doing right now, it basically looks like this. 1/2 times 11 times 21, that's A and B, times the sine of 35, the angle included by those two sides. You punch that into a calculator, and according to my calculator, this is 66.2 inches. Leave it to 2 decimal places. That should be good enough. There you go. Square, because it's area, right? Inches squared. All right, the next ones I'm doing is number 23, B and C, followed by number 24, B and C. Number 23, simplify. What I'm going to do in this one first is take that 6 and bring it inside using the power of a product rule. So basically what I'm going to get is x to the 18th, because it's 3 times 6. Y to the 1/2 times 6 is just 3, right? 6 times 1/2 is 3. Times the cube root of y to the 6. Now I'm going to simplify the cube root of y to the 6, this part right here, okay, by dividing into it. 3 goes into 6 how many times? 2, right? So that's y squared. What's the remainder of that division? Nothing. 0. 3 goes into 6 exactly twice with a remainder of 0. So there's no y left inside. The radical is gone. This is all you have. X to the 13th, y to the 3rd, y squared. Next, put these two together since they have the same base. That's y to the 5th. So your final result is x to the 13th, y to the 5th. Done. Let's do C. What I'm going to do in this one is I am going to put the two radicals together, multiply them together. This is a multiplication, and you can do that as long as they have the same index, which they do. They're both square roots, right? So 24 times 2, that's 48. C to the 7th, 4 and 3. D to the 10th, which is 2 and 8. Square root. Don't forget the square root. Now, picture the index here. I'm going to write it in. It's 2. It's not written in when it's square root, but it should be, there should be a 2 there. And then you're going to divide it in just like we did in the last problem. Okay. Before I do that, I'm going to make a factor tree for 48 to simplify it down. 48 is 2 times 24, which is 6 times 4, which is 2 times 3 here, and 2 times 2 here. So I have 1, 2, 3, 4 2's. So it's 2 to the 4th, and 1, 3. So 3 to the 1. Times c to the 7th, d to the 10th. That's what I have inside my radical with an index of 2. And then I'm just going to do a series of divisions, right? On the exponents, not on the bases. 2 goes into 4 twice. That means that this 2 comes out, 2 of them come outside. 2 squared. The remainder of that division is 0, so there are no 2's left inside the radical, which I'm going to draw here to figure out what's left inside. The 3 here has an exponent of 1. So 2 goes into 1 0 times. It doesn't work out. So the 3 is going to stay inside regardless. 2 goes into 7 3 times. 2 times 3 is 6, right? 3 times. The remainder is 1. So what we have is c cubed, because it goes into it 3 times, and a c inside because the remainder is 1. A single c. And finally, 2 goes into 10 5 times with the remainder of 0. So that means d to the 5th comes outside, and nothing else is left inside the radical. That is your final answer. And that's a 5. Done. Okay, the next ones are number 24, and I'm going to do B and C. So letter B, radical 2x minus 1 equals 4. It says solve it. To get rid of a radical, you square it, right? So I'm going to square both sides here. 2x minus 1 equals 4, and I'm going to square here, and I'm going to square here. What happens on the left side is the radical and the square are inverse operations, so you get 2x minus 1, and on the right side you get 16, 4 squared. You add 1 to both sides, you get 2x equals 17. You divide by 2, you get x equals 17 halves. Done. You can't simplify that. In all of these, it is always important to check that you don't have any extraneous solutions. Solutions that you think are actually solutions, but they don't actually work. So what I'm going to do is I'm going to plug that in to make sure it works. Okay. So what I have is radical 2 times 17 halves, that's 2x minus 1 equals 4, and see if this is actually true. 2 times 17 halves, the 2's cancel, so it's just 17 minus 1 equals 4. 17 minus 1 is 16, so radical 16 equals 4. The square root of 16 is 4, so 4 equals 4. Check, done. It works. So our solution was correct. All right, C. I'm going to do the same thing. I'm going to square both sides. So square this side, square that side. That leaves me with x minus 9 because the square and the radical cancel equals 64, right? Negative 8 times negative 8. Add 9 to both sides and you get 73. X equals 73 is your solution. But just like in the last one, let's check by plugging it in. So what you get when you plug it in is the square root of 73 minus 9 equals negative 8. 73 minus 9 is 64. So the square root of radical 64 is negative 8. And the square root of 64 is 8. Well, not negative 8. So this actually does not work, which means that there is no solution. You found one, but it doesn't actually work. Alright, the next one I'm going to do is E on that same problem. 2 plus 4x plus 1 to the power of 1/3 equals 8. What I'm going to do is I'm going to write this as a radical. So it looks like this. 2 plus the cube root of 4x plus 1 equals 8. Now what I'm going to do is kick out that 2. So I'm going to subtract 2 from both sides. The cube root of 4x plus 1 equals 6. Cube it. Cancels. 4x plus 1 equals 6 times 6 times 6 is going to be 216. Subtract 1 from both sides. You get 4x equals 215. And divide by 4. And that is your final answer. X equals 215 over 4. You could leave it as a fraction or you could write it as a decimal if you want. Now in these cases there is no need to go back and check. Okay? There are no extraneous solutions here because you have a cube root which allows for positives and negatives. So it doesn't really matter if you go back and check. Your solution here is 215 over 4.